Hey guys, Mr. Riz here. I'm going to help you guys get started on the very first lesson of Chapter 2. So this is 2.1. We're going to be looking at something known as the derivative and the tangent line problem. So our objectives here today are just to make sure we can find the slope of the tangent line of a curve at any point, and we can use the definition of the derivative, or use the limit definition to find the derivative of a function. Okay, so here we go. Got a lot of math for you, a lot of wordies, but we can approximate the slope of a secant line through the point of tangency and a second point of the curve. If C and f of C is the point of tangency and the second point on the graph of f, the slope of the secant line goes through 2 points and is given by the substitute formula. Okay, so on the right-hand side of the equation, we have all this math, but let's go through it. I think it'd be better if I could draw this out and explain as we go through this process. So I'm going to draw a curve here. I'm going to try to draw a pretty accurate curve as best as I can. All right, so say we have a function here, and I'm going to draw a line that looks like this. And I'm going to pick a point right here. I'm going to call that point C. Now, its corresponding y value would be whatever is f of C, because whatever I have for C here, I plug it into the function, and that's the y value. Now, we can't find the slope. Our goal is to find out, our goal here is to find, I'll make this a different color, like this red tangent line. This is the tangent line.
Good morning, Michael, and happy Veterans Day to you all.
Okay, so we want to find this red tangent line here. That's the goal. Well, we don't know how to find the slope at a single point, but we could find the slope at another point on the graph and that point there. So I'm going to pick this other point here. And we're going to say that this point is some change of x away. So we're going to say that this is a delta x away. So that means our new point here would be a c plus delta x. And we could find the slope of this secant. And the reason why we can find the slope of the secant is because we have two x values. We have a y value of f of c, and then technically we would have another one of f of c plus delta x. So if I wanted to find the slope of this secant line, all I would need to do here is to take our y2 minus y1, or f of c plus delta x minus f of x, and put that over. So that's y2 minus y1 over subtracting our x's, c plus delta x minus our first one, c. So this is the slope of the secant line. That's this slope right here. Now, if I wanted to convert this secant line into the tangent line, what I need to do is make this delta x get closer and closer. Remember, we could estimate the value by getting closer and closer. So if I make this delta x get smaller and smaller and smaller, in fact, if I make the limit of delta x go towards 0, we could find this. Okay, so that's our goal here, is we want to find the slope of this tangent line, and we get this equation here. The limit as delta x approaches 0 of f of c plus delta x minus f of x all over delta x. Now, this wouldn't work just for c. This would work for any point on the graph. So we can replace this with x. So we are going to have our formula coming up right here. We can say that this formula can find the slope at any point on the graph, and it will work with any x. So we can say that the limit as the change of x approaches 0 of really any f of x plus delta x, so not just c, but any x, minus any f of x would equal, now remember we had like c plus delta x minus delta x would just be delta x on the bottom. So here is the derivative formula that we will use. This is the derivative, and this will tell us the formula to find the slope at any point. Today's goal is just, can we find this derivative equation? If I give you an f of x, can we plug it into this formula here to find the derivative? Now, the way that we denote the derivative is we call this f prime of x. Saying whenever we take an equation and plug it into this formula, we have a derivative form of it, so it's f prime of that. So this is a notation we can look. We also use some other things. We might say that this is like f of x dx, or ddx, that's what I meant. Might see it as y prime. There'll be a couple other ways that we will look this, but they all basically mean the same thing. This is the derivative. So let's take our time with these, do a couple examples, and then maybe look at one of the tougher ones from the homework. I'm trying to zoom up here a little bit, write small if you can. Okay. So every one of these problems, we're going to take the limit. It's delta x goes towards 0 of f of x plus delta x minus f of x all over delta x. All right, so if I wanted to do f of x plus delta x, we're going to have the limit here. Forgot, we always start with that. This is going to be x plus delta x squared minus 9. All right, that's the first part. Then minus f of x, x squared minus 9, all over delta x. All right, so we technically have the limit that goes throughout the whole thing, but I'm just going to keep simplifying this. All right, if we were going to square the x plus delta x, this would become an x squared plus 2x delta x plus delta x squared. Then we got a minus 9, and then distribute the negative here, minus x squared plus 9. Hopefully these look familiar. We've actually done these problems before. We just never called them the derivative. We just said that this is a problem that we'll see a bunch of times later on. Okay, so let's clean this up here. All right, the x squareds cancel out the x squareds. The plus 9 and the minus 9 cancel out, and we get a 2x delta x plus delta x squared over delta x. Well, we could factor out a delta x from the top and cancel it out from the bottom. So really, going back to the limit here, we still haven't taken it yet, is really if I factor out the delta x and cancel, we get a 2x plus a single delta x. We can make a limit go towards 0. And so we get a 2x plus 0, or in a final answer, we would say the derivative f prime of x equals 2x. And there's our answer. Okay. So maybe if you want to look at the CYU right now, try to see the problems that are just as simple like x squared or x cubed, try to do those and see what we get. All right, next type of problem is what if we have a fraction? All right, so let me go ahead. We'll try to write real small here, but let's go this. So we got the limit as delta x approaches 0 of 1 over x plus delta x plus 1 minus 1 over x plus 1 all over delta x. All right, so when we have fractions, we got to get a common denominator. So I need to multiply this one by x plus 1 on the top and on the bottom. And this one I need to multiply by x plus delta x plus 1. Okay, so let's see. This one would be, now the common denominators would combine, and it'd be an x plus 1 times x plus delta x plus 1. We'd have an x plus 1 on the left side here, and then on the right side we have to distribute the negative, minus x minus delta x minus 1. All right, so let's see. The x cancels out the x. The 1 cancels out with the 1, and we get a negative delta x over an x plus 1 times an x plus delta x plus 1. Now, the other thing is we got to divide by delta x here. So instead of dividing this fraction by delta x, we can multiply by 1 over delta x, which then will cancel out this delta x. And so going back to the limit here, we will have a negative 1 over an x plus 1 times x plus delta x plus 1. So if we take the limit as delta x goes towards 0, we're going to change that delta x to a 0, and we would get negative 1 over x plus 1 times another x plus 1, because that'd just be a 0 there. And so we could say final answer here that our derivative f prime of x, our derivative is -1 over x plus 1 squared. All right. So fractions are a little bit tougher than the straight up polynomials, but we're going to spend our time with this. We're going to do 4 days of straight doing the long steps here, going through, making sure we understand the process before we start applying them. Actually, we'll start applying them, but we're going to go through this process very, very slowly here. All right, next we got a radical here, and we'll have to remember our tricks with the radicals. So let's see, we're going to have the limit as delta x approaches 0 of f plus delta x. So this is going to be 6x plus delta x. All right, minus radical 6x all over delta x. All right, so when we had radicals, we had to multiply by the conjugate. 6 times x plus delta x plus radical 6x on the top and on the bottom. Okay, so the top, let's see, the bottom is just going to be delta x times the conjugate, 6 times, radical 6 times x plus delta x, plus radical 6x, and the top here, if we distribute this, we'd have a 6 times x plus delta x, and then a minus 6x. Okay, we can probably see what's going to happen here is that if I distribute the 6 here, I'd get a 6x minus 6x, which would go away. I just have a 6 delta x on the top, and then at the bottom we have this crazy expression, delta x times the conjugate. Okay, so if we keep looking, we've done problems like this before. Our delta x's cancel, and really we have the limit as delta x approaches 0 of 6 over radical 6 times x plus delta x plus radical 6x. If we make our delta x go towards 0, we'd get 6 over radical, that'd just be a 6x plus a radical 6x, which means we would have 6 over 2 radical 6x. We can divide the 6 by 2, and we'd get 3 over radical 6x. When we add these 6x, yeah, nothing happens there. And we can kind of leave it like this. In fact, we will leave our expressions like so. Even though they're improper, it just will make solving later on easier. So the derivative is 3 over radical 6x. Okay, so let's take a look at one of the problems from the homework and do that just to help you guys out. And we'll clear that. So remember, you guys, I would recommend watching these videos again or going back and seeing if you guys had any mistakes or problems, you know, going through those things. All right, actually, are we in the second quarter now? We are in the second quarter, so make sure you guys go to the second quarter Canvas page. That's where you guys will find this information. All right, CYU 2.1, CYU-A. But preview this. Let me look for a tough problem that we could do. All right, that's going to be easy. That's easy. That's easy. Yeah. Oh, and those are multiple choice to help you out. All right, let's do this one here. That'd be a little difficult. The x cubed plus x squared. All right, so I'm going to give you guys some hints here, and it wouldn't be bad to help write these down. All right, so we're going to take the limit as delta x approaches 0. Oh, bless me. Okay, so what we got to do here is we are going to take, I'm going to try to write over here, the limit as delta x approaches 0 of x plus delta x cubed plus x plus delta x squared. Oop, I'm going to run out of room. My face is in the way. then minus x cubed plus x squared all over delta x. Okay, so maybe we will make a list of our shortcuts to use here, but x plus delta x cubed comes out to be, here we go, it is a 1x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. That's just this, FOILed out, factored, or distributed multiple times. All right, then plus x squared, x plus delta x squared. So that'd be plus x squared plus 2x delta x plus delta x squared. And then we have minus x cubed minus x squared all over delta x. Whoo-wee. Okay, so let's see what cancels out. This x cubed cancels out that x cubed. That x squared cancels out this x squared. So we'd have a 3x squared delta x plus 3x delta x squared plus a delta x cubed plus a 2x delta x plus a delta x squared. That's what's left over, and these are all still over delta x. Well, if we look, that has delta x, that has 2 of them, that has 3 of them, that has 1 of them, that has 2. So every single one of these terms in the top has a delta x. So we can cancel out a delta x from everything. We just factor it out and divide. So we'd get a 3x squared plus a 3x delta x plus now just a delta x squared, and then plus just a 2x, and then plus a delta x. So if we remember, technically we have the limit going on here, and we're going to make the limit of delta x go towards 0. So every single place we have a delta x, we're going to change that to a 0. Well, when we do that, this becomes 0, that becomes 0, and that becomes 0. So we are just left with a 3x squared plus 2x. Now make sure you guys take your time typing that in. You're going to have to type in like 3x caret 2 plus 2x. All right, and you guys should be all right with that. Okay, take your time with this. Look at the answers, make sure you guys are doing them right, and I will see you guys next time. Have a great day.